All right, here we go with objective 23, which talks about rate of change or slope. Now, this is a topic that is important in algebra, but also important in like algebra 2, pre-calc, all the way up through calculus. Rate of change comes up continually throughout all of math. So let's talk about what rate of change is. Rate of change is how quickly or slowly, so quickly or slowly, you are moving or changing. So if you're riding in the car and we want to know how fast you're going, so how quickly you're moving, that would be like a rate of change. We're talking about how much distance is changing over a unit time or your speed, right? So rate of change, you can think of slope is like how much something is changing over time, over distance, things like that. So rate of change, we denote that as the change in y over the change in x. So change in y over change in x. And we can also use that, we can abbreviate that using the Greek letter delta or just a triangle. So delta y over delta x. That's the same thing, change in y over change in x. How to determine the slope of a linear function or a linear graph? The slope between 2 points, and I'm going to go ahead and define what those points are. We're going to just call them arbitrary points, x1, y1. So that's x with a little one lower, and then y1. And we'll have another point, x2, y2. So these are just 2 points on the plane. And we're going to say that the slope is, we're going to use the letter m. So in math, whenever you see m, when talking about linear functions, m refers to the slope. So we know that slope is change in y over change in x. But we've got a formula that we can use using these 2 points. And that formula is y2 minus y1 over x2 minus x1. So notice that the y's are on top. That's always true when finding the slope. Y is always on top. So we're going to use this formula y2 minus y1 over x2 minus x1. So let's try a few examples. Here I have the points 5, 9, and 1, 5. The first thing that we do is label each of the points. So we're going to label this first one. We're going to call this one x1, y1. And we're going to label the other one x2, y2. Now, to find the slope, we're going to plug it into our formula. So our slope m equals y2 minus y1 over x2 minus x1. And now it's just plugging in what we know. Well, y2 is 5 minus y1 is 9 over x2 is 1 and x1 is 5, so minus 5. All right, and now we can evaluate. We have in the numerator 5 minus 9 is negative 4. And in the denominator, 1 minus 5 is also negative 4. Well, negative 4 over negative 4 reduces to 1. So then we can say our slope m equals 1. Let's try another example. So here we have 2 points. The first thing that we do is label our points. So step 1, we're going to label our points. x1, y1, and x2, y2. So we're going to find our slope. So using our formula, m equals y2 minus y1 over x2 minus x1. So y2 is negative 1. Y1 is 5, so minus 5. X2 is 3 minus, and x1 is negative 2. So notice in the denominator, we have 3 minus negative 2. A lot of students forget this negative 2 or this minus, and they'll just have one of them. Remember, we're subtracting x2 minus x1. So we have 3 minus negative 2. So be very careful with your notation here. Evaluating, we have -1 minus 5 is -6. And 3 minus -2, well, the minus negative is the same as adding a positive, so plus +2. So we have 5. So our slope is -6/5. Now, it doesn't matter which one you choose to be x1, y1, and x2, y2. You can flip these around. So if we were to say that -2, 5 is our x2, y2, and then the other point, 3, -1, is our x1, y1. So if we were to flip them around like this, I'll show you, we end up getting the same answer. So let's plug that in and just confirm. We have our slope m equals y2 minus y1 over x2 minus x1. So plugging this in, y2 is 5 minus y1 is -1. So here, remember the -1. So we're subtracting a negative. Over x2 is -2 and x1 is 3. So -3. So again, subtracting a negative is the same as adding a positive. So we have 6 over -2 minus 3 is -5. And these are really the same, right? You can rewrite both of these. You can pull that negative out in front and say -6/5. So we do get the same answer either way. Let's try another using a table of values. So here we've got 4 points. We've got -5, 2, 1, 5, 7, 8, 13, 11. We can choose any of these 2 points and we can use our slope formula. So let's just choose, we'll choose this one and we'll choose this one. So we'll say -5, 2 and 7, 8. Again, they can be any of those 2 points. So we'll call this first one x1, y1. We'll call this other one x2, y2. So plugging it into our formula, we have the slope equals y2 minus y1 over x2 minus x1. Well, y2 is 8 minus y1 is 2. And we have x2 is 7 and x1 is -5. So minus -5. 8 minus 2 is 6, and 7 minus -5 or plus +5 is 12. Reducing this fraction, we can pull out a factor of 6. We get 1/2. And again, your TI Nspire will also reduce these fractions for you. So I want to show you another way that we can find the slope using the table of values. So if you notice, you can use this formula, but you can also notice what's happening between each y. Remember, the slope is the change in y over change in x. So how does y change? How does it change from 2 to 5? Well, we add 3. How does it change from 5 to 8? We add 3. How does it change from 8 to 11? We add 3. So it's the same. It changes consistently. In the x, we've got -5 to 1. How does that change? We add 6. From 1 to 7, again, we add 6. And from 7 to 13, we add 6. So if the slope is the change in y over change in x, well, the change in y is +3. The change in x is +6. We reduce that. 3 over 6 is 1/2. So you see, we get the same slope here. So it doesn't matter to me which method you use, as long as you use one of these, given a table of values or 2 points. All right, let's try a few more. Go ahead and flip the page. So I've got one more example for us here. I've got the graph showing the number of houses built in any given year from 1970 to 2000. So in order to find 2 points from this graph, I got to see where it intersects the grid line really nicely. So I'm looking at this graph. Where does our graph intersect the grid lines pretty nicely? I notice like right here at 1990, 10. So I'll go ahead and plot that point. Let's see, where else does it plot nicely? Right here is pretty good. So 1994 and 15. So let's choose these 2 points as our points to find the slope. So we're going to choose the points. Our x value is 1990, and our y value is 10. We're going to choose the other point, 1994, 15. Now, this is the same as we've done in the past. So step 1, label the points. So we have x1, y1, x2, y2. To find the slope, we're going to do y2 minus y1 over x2 minus x1. So y2 is 15, y1 is 10, x2 is 1994, and x1 is 1990. So then we can evaluate. We have 15 minus 10 gives us 5. And 1994 minus 1990 is 4. So that's our slope here. We have 5/4. Another way we could find it from the graph is looking at this. Well, remember, the slope, again, is the change in y over change in x. Well, how does the y values change? How does it change vertically? So from this point to get to this point, well, we go up 1 unit. Well, 1 unit here is 5 houses. So we go up 5. And then change in x, how does it change horizontally? So to get from here to here, we're going 1, 2, 3, 4 units. Well, each unit is just a single year, so that is over 4. So our change in y over change in x is, change in y is plus 5. Our change in x is plus 4. So again, just 5/4. So again, you can use either method. That's fine either way, as long as you're using one of these. All right. So this is objective 23, determining rate of change. We'll see you tomorrow. Have a great day.